Okay, so the next ones we want to look at, I've said they're harder ones where instead of it being f of r minus f of r plus 1, it's f of r minus f of r plus 2. So we're just going to think about what the patterns will look like for this one. We're going to start off doing it in function notation, and as you remember from the previous ones, we're going to do some of them in just substitution and then some of them using the function notation, just to kind of have an understanding of how both of these look together. So here it says if u of n is some function of n minus a function of n plus 2, then we could say that the sum of u of r from r equals 1 to n would be, substituting in 1, you would have f of 1 minus f of 3. When you substitute in 2, you would then have f of 2 minus f of 4 plus f of 3 minus f of 5. So I'm just subbing in the different values as we go. And I'm going to do a little dot, dot, dot bit here as well. And I'm also going to go and do, I'm going to do 3 extra ones that I've got here, okay? So I'm going to do f of n minus 2. I'll have f of n minus 1 and f of n. So let's think what these ones would be. If this was n minus 2, there would be an f of n plus 1, and f of n plus 2, like this. So this is what the pattern would look like if we subbed in this bit here was when r equals 1, r equals 2, r equals 3, r equals n minus 2, r equals n minus 1, and r equals n. Do you think, after you've got that written down, can you see what the pattern is for this one? Yeah, so you have this one here cancelling with this. One of them down here would cancel with this one. Something down here would cancel with this one. Something would cancel with this one. Good, it's just f of 1 and f of 2 stay, and you subtract f of n minus 1 and f of n minus 2. So in the previous one, we ended up with just the corners, didn't we? This time we're going to have 2 in the corner and then 2 in the other corner as well. So it's just a slightly more complex kind of stuff that goes on here. So the summary would be that, let's get this out of that red. In this particular case would be f of 1 plus f of 2 minus, let's do that on the next line, minus f of n plus 1 minus f of n plus 2. Again, I wouldn't memorize that, but I would just think to myself, if my like nth term of the formula has a difference of the substitution of 2, it's going to be slightly more complicated. You should expect to see 4 different terms coming up in your method of differences, whereas when we did it previously, we just had 2 different terms, I think, here. Yeah. When it's just a difference of 1, you just have those 2 things, whereas our one is now looking a little bit more different. We're going to have 4 different things inside that as well. And in theory, you could come up with some other kind of combinations of this, and so we'll see later on. I've got an atypical example that will show you where the function notation can be quite useful. So we're going to do this first example. We're going to begin by recognizing that this is of the same form that we had here.
Is that like the general form?
That is like the general form, and the general form is where you have these 2 different functions being subtracted, and the second function being subtracted, the input is 2 greater than the previous input. So when you look at this one that we've got here, the second function that is being subtracted from here is the same function, apart from the input has been increased by 2, which means it's going to be of this other form. I think we've probably done an example where there's just an r plus 1, which would mean it's like the previous kind of thing that we've got. In theory, you could have it with an r plus 3. If it was an r plus 3, does anyone have any guesses of what they think this would look like? Yep. Good. So it'd be the same as this, but there'd be an extra f plus f3, and there'd be an extra minus f of n plus 3. But the algebra of that at the end of combining it all together is going to be a bit more messy because you've got like 6 different things to combine. Yeah. If you flipped them, you would get, so if it was f of n minus f of n plus 2 minus f of n, you would have these 2 and these two remaining. Kind of like we did in one of the other examples earlier on. Most of the time they should be this way round, but you know what happens in further maths. They like to say like, okay, well this is what you've been doing all year, and now in the exam we're going to make you do something completely different. So it's always good to ask these kinds of questions. And you guys are so different now at this point of your academic study than this time last year. It's just amazing to see like how much has changed over the course of a year and how much you know what's going on with all this. It's great. Okay, so we're actually just going to do this question. I'm going to just do it in the traditional kind of way of substitution, and then we'll just remind ourselves of what it looks like in the other way that we've got. So with the substitution, I'll substitute in 1, and I'll substitute in 1 for both of these. So it'll be 1 over 1 minus 1 over 3. Then I'll have 1 over 2 minus 1 over 4, plus 1 over 3 minus 1 over 5. And then I'll do a dot, dot, dot. And then I'm going to have 1 over n minus 2 plus 1 over n, minus 1 over n plus 1 over n minus 1 minus 1 over n plus 1 plus 1 over n minus 1 over n plus 2. And it's the same things we've been substituting before. This is where r is equal to 1, r is equal to 2, r is equal to 3. R is equal to n minus 2, r is equal to n minus 1, and r is equal to n. And so we should see that exact same pattern replicating, and we do because we see the third cancelling with the third, something cancelling with the quarter, something cancelling with the fifth, something would cancel with that would cancel with that. And we just get left with that same pattern of things that we'd seen previously. And that same pattern of things, if I was to go down a little bit further, is now just 1 plus a half minus 1 over n plus 1 minus 1 over n plus 2. And then the question likes you to combine these things together. So this is a 3 over 2. But I think the common denominator is going to be a 2, n plus 1, n plus 2. So there's going to be a 2, n plus 1, n plus 2, meaning I need to multiply this by n plus 1, n plus 2. And then this needs to be multiplied by a 2, n plus 2. And this needs to be multiplied by a 2, n plus 1. And then it's just a case of expanding, simplifying, and getting to whatever answer we have. So I believe that's 3n squared plus 9n plus 6 minus 2n minus 4 minus 2n minus 2 all over. So it might just be easier for you to work through this yourself and then just compare it to my answer at the end. What's our f of n in this case, Arafel?
F of n is...
Just because I'm going to want to try it in function notation, what would be the function that we have for this one here? Not sure? Anyone think they know what I mean, what the f of n bit is for this thing we're talking about here? If we're going to say it's f of n minus f of n plus 2. Just 1 over n, right? So then, because this is in that form that we've got there, if you noticed that, notice how this thing here is f of 1 plus f of 2 minus f of n plus 1 minus f of n plus 2, which is that thing that we've got here. So it's just noticing the equivalences between the function notation and the numbers that have been substituted in, okay? It's pretty simple. And I still, as I said last time, I still would want you to just do the substituting and seeing the pattern of things crossing out. But just in case they do something with this kind of twist on it, it's just nice to see that the function notation is working and it's not this magical thing of, oh, I need to try it out every time. It's the general case that we're looking at here. Had everyone got to this last bit and got the same answer? Yeah? Okay. So we're going to do one more, and then we'll do a little bit of practice, or maybe we'll just do the atypical example, and then the rest, that's the whole of the learning done for this, okay? So there's another partial fractions kind of question here. It's really just going to be just the same as the previous one. You should notice, though, straight away that this one is going to end up as being one of these new types of problems. Why is this one going to end up being one of the new types of problems? Yeah, it's r plus 1 and r plus 3, so there's a difference of 2 there. But didn't we do one previously where there was one with a plus 1 and one with a plus 3? What was different when we did it previously with a plus 1 and a plus 3? Does anyone remember? I'll show you and see if we can see what the difference is. Here's one with r plus 1, r plus 3. Yeah, it was a 2r. And do you remember how the 2 actually meant that there's still a difference of 1 between the things? When you substitute in r, that's like substituting in an r, and that's substituting in an r plus 1 in place of r. So that one is of a different form because of the 2 that we've got there. So we're basically doing the same question again, but this time we don't have 2r plus 1 and 2r plus 3. We've just got r plus 1 and r plus 3. So we'll do some partial fractions very quickly. So 2r plus 1 r plus 3. So it's going to be a over r plus 1 plus b over r plus 3. So 2 is ar plus 3 plus br plus 1. Well, if r is minus 3, 2 is equal to minus 2b. So b is minus 1. And if r is minus 1, then 2 is equal to 2a. So a is equal to 1. So 2 over r plus 1 r plus 3 is 1 over r plus 1 minus 1 over r plus 3. So this does look like it's of the form f of n minus f of n plus 2, doesn't it? So actually it's going to be really easy. If we wanted to go straight to using the function notation for this one, we could say that the sum from r equals 1 to n of 2 over r plus 1 r plus 3 is going to be equal to, remember it's f of 1 plus f of 2 minus f of n plus 1 minus f of n plus 2. We're going to do it the long way as well, but we're going to just try it this way. So we think it will be when you put in 1 in here, you get a half. When you put 2 in here, you get a third. Then you're going to be minusing f of n plus 1. That's going to be f of n plus 1, which is n plus 2. And you're going to be minusing the next one, which is n plus 3. And another clue how I knew it was going to be n plus 2 and n plus 3 is also they appear here as well. So that's what we're expecting to see when we do the substitution into this expression, but that's how it's going to be matching up with what we had earlier, because we have f of 1 plus f of 2 minus f of n plus 1 minus f of n plus 2. Notice here though, when it's f of n plus 1, it's 1 over n plus 2, because the function is actually 1 over r plus the extra 1. That's why there's the extra 1 here, here and here. Again, I don't think this is the best way to do it. I think this is great if you've been studying this topic for a few lessons, but if you went into the exam, you probably wouldn't remember that formula, so we're going to look at doing it with the substitution as well. So that's what we're anticipating to see. But part B of the question...
Are you allowed to use that in the exam?
Yep, I mean, as far as... yeah, I don't see why you couldn't use that in the exam. Because it's used in all of the solution bank, it's used in... It's a standard result for those things. So if if it was done and for some reason you were penalised for it, like it wouldn't be a right thing to do, but you should see there's a question we're about to do. It's 5 marks. Like, it's not even a very high mark kind of question. So, I don't know. I think it's a good way of doing it if you can remember it. Okay, so we'll do the substitution. But we know exactly what's going to happen here. So when I put in r equals 1 into this thing up here, we'd have a half minus a quarter.
Do you have to show that?
We're not sure. I'm not sure because I haven't marked this before. I'll show you a mark scheme in a second. They do have a process that I can look at some of the details. Then we're going to have a third minus a fifth. And then we're going to have a quarter minus a sixth. And then we'll have 1 over n minus 1 plus 1 over n plus 1 plus 1 over n. I always do plus there. I don't mean to. So this was r equals 1, r equals 2, r equals 3, r equals n minus 2, r equals n minus 1, and r equals n. And we get that cancels. And we get left with the same thing. We get left with a half plus a third minus 1 over n plus 2 minus 1 over n plus 3. Not surprising, we came up with the same thing there. And then the last part of this question is really just putting it all together, isn't it? So I guess my technique to begin with would be to do a half plus a third, which is 5/6. 1, 2, 3, yeah, 5/6. So it's 5/6 minus 1 over n plus 2 minus 1 over n plus 3. So my common denominator will be this. And we'll just expand and go from there. Have I done that right? Oh no, I did something wrong. Oh, yep. Okay, hopefully you've got to that answer. The last bit's pretty straightforward again. It's just doing what we've done previously. You may need a bit more space for these questions. There's quite a lot going on. All it wants us to do is actually to evaluate the answer between 21 and 30. So all we're going to do for part C, if we're trying to do between 21 and 30 of this sequence, I can't be bothered to write the thing out, so I'm just going to call it u of n. I should have said somewhere what u of n is equal to, but I'm just being lazy. We know that that's going to be from r equals 1 to 30 minus from r equals 1 to 20. Good, because we want it to start at 21. So all you're going to do is literally just substitute 30 into this formula and 20 into this formula and subtract them. So that would be 30 times 5 is 150, so it's 163, divided by 6 times 32 times 33, minus 20 times 113, 6, 22, 23, and just type it into the calculator. I think you get this, but it wanted it 5 decimal places. And I think you can probably put it on your calculator because of the graphics ones we've got up. I want to see if we can actually do that. I'm sure you can.